Good morning friends, welcome back to my channel Coding Environment. In last video, we have seen how we can reverse a given linked list recursively. In this video, I am going to show you how we can reverse the same given linked list iteratively. So this is our given linked list, right? Where we have some 5 nodes in it. So this is my first node. Again, this is my second node. This is my third node. This will be my fourth node, and this is my fifth node. Now, suppose if I have to reverse this linked list, what we have to do? We have to move this head node from my first node to this fifth node, right? So at the end, after reversing my given linked list, my first node should be nothing but the fifth node, which is this, right? This will be my head node. But will this be pointing to null? No, right? This will be pointing to my fourth node. So if I say like this, and this is my representing in the reverse linked list, this will be the first node and this will be the second node. But here, this is my fourth node. So if you see, this node should point to this node, right? It should not point to null. So somehow we have to make this node to point to this node. So if you see, if you are here, you have to point to its previous node. So for fifth, fourth is your previous node. Similarly for fourth, third is the previous node. And after reversing, this fourth will be pointing to your third node only, right? So if this is your 40, the next will be pointing to this. And this is basically your third node. So if you see, if you are assuming that this is the head node after reversing, it is just pointing to its previous node. It is just pointing to its previous node. Similarly, the fourth node is also pointing to its previous node, and keep on doing this. And at the end, the first node should point to null now. So this should not point to the next node. This will be pointing to null because this will become as the end node of your given linked list, right? So after reversing, what will be your given linked list? After reversing, this 30 will be pointing to this 30 will be pointing to 20, and 20 will be pointing to 10. But 10 will be pointing to null. So how we can do this? So to achieve this, right, we need to move this head one by one. So from here, we have to move it to here. Again, from here, we have to move it to here, and from here to here. Keep on doing this unless your head is not equal to null. Unless your head is not equal to null. So you have to keep on doing this. And when you move from one node to the other node, you have to point this node to previous node also, right? So somehow you have to keep a track of your previous node also. So basically what you need one node which is nothing but your current node, and one node which is nothing but the previous node. And at the starting, your current node will be pointing to head. So your current node will be pointing to this part. And your previous node, for this there is no previous, right? So it is pointing to null. And now we have to move our current to next node. Keep on doing this. And whenever you move your current to the next node, then this next node should point to its previous node. So you have to keep a track of your previous node also. So let me give you a small snippet and show you how you can do this. So see, if you run your while loop till your current is not equal to null, and you have to move this to here, right? So there will be one temporary variable we will keep, which will say what is the next. So we'll keep a temporary variable called next and assign your current dot next into it, right? So what we are doing, we are keeping this next variable, this next node into one of your next variable. So this is just a temporary variable. We will keep the next value of the node. And then what you have to do, you have to make your current to point to its previous. So here there is nothing. So what you can do, you can make your current dot next to point to previous, right? And once you point to its previous, once your current dot next is pointing to previous, you have to keep the track of your previous also. So once your current will move to the next node, your current will become the previous. Once your current will move to this next node, this will become the previous, right? So before you move it to the next node, you store your current value into this previous, because this will become the previous for the next node. And then you have to make your current is equal to next. So because you have stored this next of this current here, right? So this is the 4 line of code you have to write to reverse your linked list. And once the linked list is reversed, where will be your head? So once your linked list will be reversed, where your head will be? It will be stored into the previous node. So let's run this piece of code one by one as a dry run, and let's see how this thing is happening. So this is the code I just explained to you, this while loop. And these two variables, as I explained, right? This current will be keep on moving from first node to second node to third node, third to fourth to fifth, and at the last it will pointing to null. So your current will go till null. And then you have to keep the track of your previous node also, right? So you'll keep the track of your previous node using this previous variable. And this node is just a temporary node which will hold the next node in it. Now let's run this code one by one and see how it will happen. So in the first time, when you will pass this head to this method, the head will be pointing to this 10. Your head will be pointing to this 10, right? Now your current is again, so your current is nothing but your head, right? So it is again pointing to this. So at this point, your current is pointing to 10. And what is the previous? Previous is your null, right? So previous is nothing but your null. Next is null again. So if this is the first line, current is not equal to null, what will happen? Your next will now store this 20. So at the dry run 1, your next is equal to 20, correct? And current dot next is equal to previous. And what is the previous value? So in this case, if you do this, your current dot next, it means your 10 dot next will be pointing to null, because it is pointing to previous, and previous is currently null. And now you have to store this current into the previous, so the next time we can use this previous node also. So after doing this operation, your previous will be holding your current value, which is nothing but the 10. And then your current will point to the next, which is nothing but the 20. So after your first dry run, your current is pointing to 20 and your previous is pointing to 10, right? And what will happen in the dry run 2? Let's see it. So your current is still not equal to null, right? Then the next will point to this dot next, which is nothing but the 30. And then your current dot next is equal to previous. So current dot next, so this will point to 10, because your previous is pointing to 10 here, right? So your here, like this node I showed, right? This thing will happen by this current dot previous, right? And then your previous will again hold your current value, which is nothing but the 20. So you can see it. We are moving one by one. We are moving one node each time and making the next node of the current node to point to its previous node. So similarly, thing will happen into this dry run 3 also. Just let's do this also. So in this case, what will be your next value? The next value will be nothing but the 40. And then your 40 will be, and then your 30 will be pointing to 20 by again using this line. And then the previous will store this 30. So what will happen here? Your previous will store the 30. And what will happen to the current? Current will now move to 40. Here also your current was now move to 30. So you can see it. We are moving one by one and then pointing the current node to its previous node. So same thing will keep on happening. So we have seen till dry run 3, right? Let's do the dry run 4 now here. In this case, again, what will happen? Your next will now store which one? Your next will store 50. Your next will store 50. Your previous will store your 40. And then again, your current will move to 50. And in between this, your 40 will be pointing to this 30. Again, in the dry run 5, what will happen? Again, this is not null, right? So what will happen? Your next is now pointing to null. At the dry run 5th, your next will be pointing to null, and your previous, which is nothing but it will be pointing to 50, and again your current will be pointing to null because current is equal to next here, right? Now see, after this dry run 5, your current becomes null, correct? And this will fail this condition where current is not equal to null. Now you can see it, your previous is basically holding your last node here. So at the end, when your current is equal to null, basically your previous is holding this last node, which is nothing but 50. So what is your head node in this case? It is nothing but your previous node. So you have to return your previous node from here so that it will act as a head node for your return linked list. I hope you liked this video and understood this program. If you understood it, please write understood in the comment section and subscribe to my channel. Till then, have a great day and goodbye.